All right, good morning, students. We're going to start a little part of our circles unit. I'm going to slowly bring in circles throughout the year. It's an entire unit in the module in the second semester, but instead of waiting until the end, I'm going to start bringing parts of it slowly by slowly. It's major in the park. There's been at least 5 questions on average each year on circles. And I don't want to get caught at the end having to scramble to fit it all in there before the park test itself, now called the DCAS. Uh, so if I say parks, the same thing as DCAS. That's the new name for it. Anyway, so we're going to review some vocab here. We talked about some of these vocab words already in a previous or in class prior, but here it's now being officially stated to you. So write down all this vocab along the way. What you can do when we go to the next page is you could pause the video at any time and you try to answer the questions yourself and then hit play and see as I work out the problems and or give you answers if you got them correct based off of what I show you on this first screen right here. Okay, so we're going to start by going down this right side right here, and then we'll bring in these pieces along the way when they come up. First off, you name a circle by its center point. So we look here at center point. There has to be a point there. If you don't see a point there, we don't know where the center is. And therefore you can't call the circle anything. You can't use any points on this. All circles are named by the letter in the middle. Now they may go ahead and state that what that letter would be in the problem itself without putting the point on there. So it's either got to be in the problem itself or you have to see a point in the letter, and that's how you name a circle. This is the circle symbol. That little dot would be right in the middle. Okay, if I could move it, I'd move it. Okay, and then circle O is the name of that there. AB, you should know, is a diameter. Diameter has to go through the center of the circle. Okay, and we should all know that OA, OB, and OD segments, those segments are called radii, plural of radius. And you should know that all radii are congruent. So if I didn't have all these other pieces on there, I could put a single hash mark there, a single hash mark here, and a single hash mark here, showing that all radii are congruent. Now, this vocab again will be on your quiz and test as we go through. Okay, it could just be identifying. Name the chord, for example, or the tangent, or a secant. Okay, so make sure you're memorizing, not only taking notes on this, but then memorizing the vocab along the way. And I'll be asking for extra credit in class. Who can tell me the definition, for example, of a tangent? A tangent can be a ray, segment, or a line that only touches the circle in one point. In this case, point D. So this is line FG is tangent to circle O at point D. Okay, when it's tangent, meaning it only touches one spot on the circle, that if I drew a segment from that point to the center, that's a radius obviously, because any point on the circle to the center is a radius, that angle will always be 90 degrees or perpendicular. Okay, you can say that line FG is perpendicular to the center of the circle. Okay, it's always going to be 90 degrees. So later on, when we get in more problems with that, in the circle unit and that kind of thing, you have to know to put that right angle symbol there. They are not going to put it there for you. They want to see if you remember that all tangents are 90 degrees to the center of the circle. So memorize that now. I can throw that on a quiz or test. Anything I'm giving you here is good to go for the rest of the year on a quiz or test. All right, next we have angle CAB. This angle right here that I put an arc on. Okay, that normally would not be there. I just drew it in here to signal out where that angle was. Okay, you should know how to name that angle. That's called inscribed angle. An inscribed angle has the angle on the circle. So its vertex must be on the circle. So therefore, this angle is not an inscribed angle because it's not on the circle. It's inside the circle. This angle here, this angle here, this angle here, and this angle here are not inscribed angles because they are not on the circle. They are inside the circle. Inscribed angle must have its vertex on the circle. Okay, that's called inscribed angle. So what can we learn about an inscribed angle? What's true about it, besides the definition of how you find one? An inscribed angle, as it says, must be on the circle, not inside the circle. And an inscribed angle is always half of its intercepted arc. So its intercepted arc, if I go ahead and go out where the angle was created right there and there, and then the arc is arc BC, is what we'd call that. Okay, I forgot to write how you can write arc BC, so here, let's put that in here now. Arc BC, you have BC, and then you have a little arc symbol on it. That's like a semicircle. It's supposed to be a semicircle. Okay, it's hard to draw it on here. And that's an arc. So arc BC will be 80 degrees. I put that degree sign there. So arc BC equals 80 degrees because we see 80 degrees right there. So an inscribed angle is always half of its intercepted arc. So what's half of 80? 40. So right there is 40 degrees because half of its intercepted arc. And I wrote that down here. The measure of angle CAB is 40 degrees. Remember, M stands for measure, which means it must be a number. I don't put letters here. It's the measure. Measure is a number. 40 degrees. So we're going to practice these problems on the next page. Okay, so I can either, if they didn't give me that 80, but they gave me the 40 here, since I know this is half of the arc, I can double that 40 to put the 80 there. Okay, because remember, this is half of this, so if I double this, it gives me the arc itself, 80. Okay, next, angle BOD, so this angle right here is called a central angle. Any angle, same as AOD, is also a central angle. Any angle that has the center as its vertex is called a central angle. A central angle equals its arc measure. Remember, the inscribed angle equals half of its arc measure. The center angle equals its arc measure. So remember, to find that arc measure, I just go out here and go out here, and then I would connect that arc. So this 125 degrees is to represent the entire arc. Okay, just so you know that, I put this, what's called a secant, coming in later. Okay, but this 125 was meant to represent the whole arc BD. Okay, so that means the central angle is 125 right there. Central angle equals its arc. Intercept arc. Now, don't forget, semicircle, half of a circle, right? That's half of a circle, because there's my diameter, is 180 degrees. So if this arc BD is 125, then I can get arc AD by doing 180 minus 125, which puts that at 55. Okay, for a total of 180 degrees. There's my semicircle. Remember, if that's 55 degrees, what else must be 55 degrees? It's central angle, right there. Central angle equals its arc measure. The inscribed angle equals half of its arc. Central angle equals its arc. Remember this. It's on the quiz and test. Okay. So I went ahead and wrote this measure angle BOC. That angle right there is 125 degrees. All right. Naming arcs. We have minor arcs, which are between 0 and 180 degrees, and major arcs between 180 and 360 degrees. Notice it does not include them because we know 180 degrees is a semicircle. Okay, and then 360 degrees is a full circle. Okay, so the arcs are in between those. Minor, it's what we think of as an acute angle. If you want to think of it that way, acute would be between 0 and 90 versus obtuse between 90 and 180. Well, the minor, in this case for a circle, is between 0 and 180, and the major between 180 and 360. Minor arcs are usually only named by 2 letters. Okay, if it only has 2 letters, it has to be a minor arc. It could still be a minor arc with 3, okay, but if it only has 2, it has to be a minor arc. So your degree answer better be between 0 and 180. So what does this mean? So let's take a look at arc BC. BC, since it only has 2 letters, the answer has to be between 0 and 180. So that means I have to go from this way to this way for B to C. I'm not going to go all the way around here, starting at B, come all the way around here to C. That's a major arc. Okay, way more than 180 degrees. Remember, the whole circle is 360, so that's 80. That means the whole rest going this way all the way around would be 280 degrees. Plus that 80 is 360. So if I went BC this way, that'd be 280 degrees. That is not between 0 and 180. So I have to go the short route right here, 80 degrees. So if it's only got 2 letters, it's got to be a minor arc. Okay, now this is a minor arc right here, right from C to A. Okay, but I could also call it arc CJA. That's the same thing as CA. Because remember, CA means if I only have 2 letters, I have to go the short distance, the minor arc. I can't go CA this way because that's more than 180 degrees. Okay, so if it's 2 letters, just remember it has to be a minor arc between 0 and 0. You go the short route, not the long distance around to connect B to C or whatever arcs you're talking about here. Major arcs are usually always named by 3 letters. Okay, unless you literally didn't have, no, you're going to have to. It has to be 3 letters. Okay, so if I wanted it to be this arc, I would call it BDC, for example. That would tell me you start at B, go through D, all the way to C. I could have also called it BKC, 3 letters. I could have called it BAC. I could have called it BJC. They're all the same. Starts at B, goes through one of these letters all the way to C. And then that would be 280 degrees because we had that as 80. 360 minus the 80 is 280. Okay, and that would make sense. It's between 180 and 360. So that's called a major arc. All right, we talked about the word chord before. Chord is any segment that has its endpoints on the circle. So segment CA is a chord, segment BA is a chord. Those are the only 2 chords we have here. Remember, OD is called a radius. OA is a radius, OB is a radius. We also, if we just talk about this segment, KJ would be a chord. Okay, we're just going from here to here, not including the rest of the line. Okay, so KJ, segment, KJ, you have to have the segment symbol above it. That would be a chord as well. The longest chord in a circle, we talked about this before, the longest chord in a circle is always the diameter. That's a quiz question. Okay, so in this case, it would be segment BA or segment AB. Remember, the order on segments don't matter. I can call it BA or AB with the segment bar above it. All right, next vocab word is secant. Any segment, ray, or line that goes through a circle twice. So here, remember, tangent touches once and is perpendicular to the center of the circle. A secant touches twice, goes through twice. It could be a line, as it is here. It could start out here and go all the way to J and be a segment, but it started on the outside and hit here and ended here, so it goes through twice. Okay, and it could be a ray. It could just start here and go through K and keep going through J forever. Those are called secants. Okay, and as it says here, if I extended segment AC, okay, in both directions, so made a line, that'd be a secant. If I extended OD in both directions, that would be a secant. Okay, or if I extended AB in both directions, it would be a secant. Okay, it has to start on the outside somewhere. It has to have points on the outside, come in through and hit at least one other point on the circle. It can stop there, but it can also keep going. It's called secant. So there are rules that we'll get into more with secants and chords and the angles and the distances that they create and all that kind of stuff, formulas, when we get more into the circles unit. I'm just introducing the vocab of those words here today. So we're going to focus figuring out problems dealing with the inscribed angle, for example. Okay, so let's turn to the page. So here we go. An inscribed angle, remember, has its vertex on the circle. So in this case, this angle right here, remember, it is half of its intercepted arc. So the green is the intercepted arc. So what is half of 116? Again, you could pause the video right now and try to answer all these questions on your own, or do one at a time, you know, and then hit play to see if you got it right. So again, half of 116 would be 58. So that'd be 58 degrees. right there. Okay, you can pause and keep trying to hear. Notice, this is a right angle symbol. How many degrees is that? 90. Remember, that means 90 degrees is half of its intercepted arc. So how do I go from the inscribed angle to the intercepted arc? I double it. So double 90 is 180. So that's 180 degrees from there to there. Side note, that means that's 180 degrees. That means if I connect this segment to this segment, it would be a segment. So let's get rid of that instead of a ray, because I just put in there. That means that this endpoint here, oh dang it, it's still a ray. Change it over to segment. There we go. Now I have it as a segment. So if I connect those two, that since that's 180 degrees, we know that that's going to go through the center of the circle. Okay, so that forms a semicircle. So 180. Okay, here, notice I have to figure out both of these. Well, what I need to remember is a circle is 360 degrees. I pointed out right here. All the arcs of a circle out at 360 degrees, just like the angles out of 360 of a circle. Semicircle, which is half of a circle, is 180 degrees. Okay, so we know all that arc plus arc A has to add to 360. So here I have 60 plus 82 is 142. So I do 360 minus 142, and that equals 218. So that means A is 218. Okay, well, remember this is called inscribed angle. The inscribed angle is half of its arc, or its arc goes from here all the way to there. That's the A, 218. So what's half of 218? 109. So B is 109. Okay, let's go over here to number 9. Again, I have this arc is 60 degrees, so that tells me its inscribed angle is 30 degrees. So B is 30. Again, I have an arc right here, which creates this angle. So the arc is 108. Half of 108 is 54. So A is 54. Well, now it asks for C. Well, isn't C? Can I move this across and make it C there for vertical angle theorem? And then I have the triangle sum theorem that these three angles must add to 180 degrees. So I can put C right there. Okay, and then C plus 30 plus 54 equals 180. So we have C plus 84, when combined like terms, equals 180. So C subtract 84 across, and that gives me 96. So C is 96 degrees. Okay, next one. So remember, this starts. You have to start thinking a little bit more here now. So first off, if I look here, 71 degrees. Remember that comes from that angle right there, 71. So that means this arc from here to here, or touches, extend that has to be double that, 142. Well, we know from here to here is 104. The whole distance, this whole arc has to be 142. So what's 142 minus 104? 38 degrees. So now we have C is 38. I can figure out that one. Okay. Now what else? So let me go ahead and erase that piece. So we just figured out what C was. Okay. So now 68. Remember, 68 is half of its intercepted arc. So if I need to see where that arc goes, go along that angle right there. So this arc from here to here is double this, 136. Well, don't forget, from here to here is 38. So I go 136 minus that 38 would be 92. I mean, it's 136 minus 38, 198. I mean, 98. 98 plus 38 is 136. So now I have that arc from there to there, 98 degrees. Okay. So now, notice I have this arc plus this arc plus this arc. The only arc left that I haven't done yet is B. Well, don't forget, B, all the arcs combined together is 360 degrees. So I could say B plus 104 plus 38 plus 98 adds to 360 for the full circle and get B that way. And that's what I need to go ahead and do. Okay, so I'm just combining like terms now. B plus 98 and 38 is 136, 236, 240 equals 360 degrees. So therefore B, subtract the 240 across and you get B equals 120 degrees. So now B is 120. Okay, so you have to remember arcs at 360 degrees, all of them in the whole circle. We know the inscribed angle is half of its arc. So I take that angle and double it. That gave me the 136. I double that, gave me the 142. Okay, so that's how you figure out this one. Now, I can do the same thing with this one here, but another rule is if I have an inscribed quadrilateral, remember inscribed means the angles, all the angles are on the circle itself. You notice all four of these angles are on the circle. If I have an inscribed quadrilateral, remember quadrilateral means four sides, so this is called inscribed quadrilateral. The sum of its measures is 360 degrees. Okay, so all four of these angles have to add to 360. Okay, we can also know that inscribed angles half this intercept arc. So for example, if I have, this is 100 degrees, then this arc from here, A plus the 99, has to add up to 200. So I do the 200 minus the 99, gives me 101 right there for the A. Okay, well, this one, so if I erase that off now, okay, well now for the 96, that goes from there to there, 96, so that means this arc, the 99 plus this arc, has to equal double that, which is 192. So I have 192 for the whole thing minus this 99. It gives me this one right here. So that gives me 93. 93 plus 99 is 192. Okay. And let's see. I was trying to see if I could, let me erase these now so I can get those that way. Now, the other thing that we would have, okay, so if I did this one, remember that's going to be that arc plus that arc, which I don't have. If I do this one, it's this arc plus this arc, which I don't have. The other thing with an inscribed quadrilateral is that the opposite angles, opposite means across from, the opposite angles are supplementary. Remember we just had supplementary, that's going to be on your test. Supplementary means two angles add to 180. So this angle plus D has to be 180, so that makes D 80 degrees. That's another rule for inscribed quadrilaterals. So I could have gotten these two angles right away just from doing the supplementary a bit quicker than what I did here. And so 96 plus what equals 180? 84. So now we have those two. And then if I add them all up, that'd be 360 degrees. So now I can figure out what B is, okay? Because remember 84, that means this intercepted arc from here to here, that's for the 84, has to be double that, 168. Remember that was 101, so 168 minus 101, 168 minus 101 is 67. So that was B is 67. And now I have all the angles. Okay, I could have double checked that from this arc here, 80. Remember that's 80, so that means this inscribed angle has to add up to 160. And 93 plus 67 is 160. So I can double check that I did that right by using this arc this inscribed angle equals 160. Okay, so in regards to this would be the most complicated one. Okay, just remember inscribed quadrilateral, all the angles have to add to 360, and the opposite angles are supplementary, means they add to 180. All right, so now we have solve for x in here. Okay, so here's the x. Okay, well, if I look right here, remember this is an inscribed angle, so that means it's intercepted arc. This entire arc from here all the way around to right there. Doing it quicker, has to be 210 degrees. 220 degrees, double that. 220. So now I have 220 plus the 50 plus the 30x. That creates the whole entire circle, all the arcs, and we know all the arcs around a circle after 360. So that 220 plus 50, combining like terms, is 270 plus 30x equals 360. So now I go ahead and subtract the 270 across, and I get 90 degrees. And last step, divide by 30 on both sides, the division property of equality. So remember this would have been the subtraction property of equality when I subtract the 270 across, and now I have the division property of equality going from here to here, and x is 3. So we solve for x correctly. Okay, here, remember, this angle equals half of this angle. So what is half of 192? Take 192 divided by 2. Divided by 2 equals 96. So that means 31x plus 3. 31x plus 3 has to equal 96. Oops, 96. Okay. Subtract the 3 across. That'd be subtraction property of equality. Equals 93. And last step, divide by 31 on both sides, the division property of equality. And that gives me 3. X is 3. So both of these cases, they count to be 3. It just happens to be. Okay. So that's how you deal with variables. Now, any of these types of questions could be on your quiz or in our tests. What I would do is I'd probably just make my life easier. Just create a drawing similar to these and just change the numbers. Okay, but you'd solve them all the same way, just different numbers. You know, I could have a different algebraic expression here and a different number here. Do the same steps. All right, last page. A couple problems here to look at. Okay, similar to what we just got done talking about. Okay, what I've already explained on the last pages. Nothing new here. Okay, so notice this is a diameter. You're always looking for a diameter here. So that means these two, this whole side has to be 180 degrees. So I have 2 full arcs here. So that means this arc plus this arc has to add to 180. So I go ahead and I'm just going to combine like terms right now. 13x plus 7x is 20x. Minus 10 and minus 10 is minus 20 equals 180 degrees, the semicircle. Okay, now we do the addition property of equality because we're adding 20 across each side. And last step, the division property of equality, dividing by 20 on each side. And 200 divided by 20 is 10, so x is 10. Now that's what x is. Go back and read the directions. It wants the measure of the angle NLM. It wants this angle right here. That's what it's asking for. That angle. What is that angle it's saying? Well, my arc should be drawn like this. Okay, so we're talking about this angle. It's hard to use this. Okay, NLM. Remember, L is called the vertex. Okay, so what is this? We know it's half. This angle is called an inscribed angle, remember, because the angle on the circle. The inscribed angle is half of this arc. Well, now I have the x. I can plug it in right there and get this arc's measure. 7 times 10 is 70. Minus 10 is 60. So that arc equals 60 degrees right there. Okay, remember the inscribed angle is always half of its arc. So what's half of 60? 30. Okay, and now we come over here. Remember, we have an inscribed quadrilateral because, again, all 4 angles are on the circle. And as I just pointed out on the last page, the opposite angles are supplementary. That's where this comes into play. You have to remember that. So that means this angle plus this angle adds to 180. So I just add these two together, set equal to 180. They're supplementary. Remember, that's the word for supplementary, two angles that add to 180. So I'm just combine like terms right now. So 38 and 21 is 59x. And 5 minus 2 is plus 3 equals 180. And now we do the subtraction property of equality. Subtract 3 from both sides, you get 177. And division property of equality, divide by 59 on both sides, and you get 3. Boy, I like to have 3 for their answer on these ones I've been choosing. So x is 3. Go back and read the question. Notice you want the measure of the arc. Remember, there's your arc symbol, FGH. So F, G, start at F, go through G, all the way over to H. They want that arc measure. Well, where does that come from? That comes from this angle right here, right? That inscribed angle that created that arc. So we want to find this angle measure, and then how do we go from here to its arc measure from the last page? Double it, because this is half of its arc. So now we can plug in the 3 here. 38 times 3. 3 times 30 is 90. Plus 3 times 8 is 24. 90 plus 24 is 114. Plus 5 is 119. So 119 right there, plug in the 3. And remember, since that's the inscribed angle, we double it to get its arc measure. So double 119 gives you 238. And so that is my answer. Arc of measure FGH. So again, measure tells me it wants a number. It's the FGH. It tells me what way to go. I can't go just F to H. That'd be FAH if I wanted there. They wanted FGH, going around that way. Start at F, go through G, end at H. So the answer is 238 degrees. So now I'm going to give you a worksheet dealing with this for you to practice. Again, you could always go back and practice these on your own or rewatch it. And these will be on the park. They'll also be therefore in your quiz and tests as well coming up. So this is the only part that we're going to focus on right now. We're going to actually I'll add in one more with circles themselves and the equation of circles. But then the rest of the circle unit, we're going to wait till we get to the circle unit. But I want to get, it's about half to, maybe 40% what we're covering right now. The other 60% will come into the unit itself. So I want to get this in during the first semester. Like I said, this is highly done on the park. Okay, you have inscribed angles, you have the inscribed quadrilateral in there. You got to remember they add up to 360. The opposite angles are supplementary. Okay, guaranteed you're going to probably have both of these types on the park. Okay, along with just knowing your vocab. But the other stuff will come with the equation of the circles. I'm going to bring in another video next on, and then the rest of it we'll do when we get to the circle unit. All right, that ends this video.